So in the previous video, we learned how to convert between numbers of particles, which are usually going to be absolutely massive numbers for any type of reaction you're likely to do, and number of moles, which is our way of grouping those particles into a more kind of manageable number of things to think about. So instead of thinking about, oh, I have 6 times 10 to the 23rd molecules here, I have a mole, is just easier to deal with. But that still is not, practically speaking, how we measure stuff in the lab. That if I tell you to go do a reaction in the lab, I'm not going to tell you, go get a mole of this substance, because we can't directly measure a mole using common laboratory tools. What you usually have is something like, go get a gram of this substance, or maybe 10 milliliters of this substance. So today we're going to learn, how do we convert between moles and mass? And mass is something that's much easier for us to measure, but we need another sort of tool in our tool belt here, another type of unit conversion to convert between moles and grams. So because, as we know, different elements have different masses, different atomic masses. The mass is listed on the periodic table. That means that if a mole is always the same number of particles, but if those particles have different masses, a mole of different substances will weigh different amounts. So we know particles of different substances have different masses. So in order to convert between moles of something and the mass, we need to know how much 1 mole weighs. So this quantity, how much 1 mole of something weighs, is known as the molar mass, and it generally has units of grams per mole. So that if you know that you want 1 mole of stuff to react, if you know the molar mass, you can go weigh that out on the scale now. And that is a much more practical way to do things. So the next question is, how do we figure out the molar mass of a substance? So because of the way that Avogadro's number is defined and the mole is defined, the mass on the periodic table can actually be interpreted 2 different ways. So the way that you are used to interpreting the mass on the periodic table is as the mass in atomic mass units of a single atom, that it is essentially, the number of protons plus the number of neutrons plus a little bit of weirdness due to different isotopes, and some other factors. So that's how you're used to thinking about the mass on the periodic table. It is the mass of a single atom in atomic mass units. But again, because of that definition of the mole, of the number of particles in 12 grams of carbon-12, what that means is that the mass on the periodic table is also representative of the mass in grams of 1 mole of atoms, aka it is also molar mass of that element. So that is why the mole is defined the way it is because it makes those masses on the periodic table extra useful to us. That usually the way we use them in chemistry is as the molar mass, because that's how we actually do things in the lab. So for an individual element, if you need to look at if you need the molar mass, all you have to do is look at the periodic table. If you're dealing with a compound, which most of the time we are, all we have to do is add up the molar masses of all of our atoms. So, for instance, if we wanted to figure out how many moles of molecules are in 100 grams of NH3. Anytime you are converting between grams and moles, we need the molar mass of that substance in order to do that. So we're going to need to first find the molar mass of NH3. So the molar mass of NH3 is just going to be the molar mass of nitrogen from the periodic table, which is 14.007, plus 3 times the molar mass of hydrogen from the periodic table. Since there are 3 atoms of hydrogen, we need to multiply that molar mass by 3 because that mass on the periodic table represents the 1 mole of individual atoms. And if we had a whole mole of ammonia molecules, we would actually have 3 moles of hydrogen atoms. So we're just finding the masses on from our periodic table. So this was the mass of nitrogen. This was the mass of hydrogen from our periodic table, multiplying the hydrogen by the subscript and then adding the nitrogen together gets us a molar mass of, move this down a little bit, beautiful, gets us a molar mass of, nope, decimal point in the wrong place, 17.031 grams in 1 mole of NH3. So what this is telling us is that this is our conversion factor, that 17.031 grams of NH3 is equivalent to 1 mole of NH3. So we can now use this to convert between moles of ammonia and mass of ammonia however we want. In this case, we are specifically asked how many moles are in 100 grams. So if we're starting out with 100 grams of NH3, again, we need to think about making our units cancel. If we're starting out in grams, we need grams to cancel, so the grams part has to go on the bottom. So we said 17.013 grams of ammonia was equivalent to 1 mole of ammonia. So our molar mass goes on the bottom so that grams cancels grams, leaves us in moles, which is what we were looking to find. And this is going to come out to about 5.87 moles of ammonia or so. So let's look at one more example. Let's say, what is the mass of 2.5 moles of, sure, acetylene gas, C2H2, why not? So pause here, see if you can try this one on your own, and then we'll do it together. So once again, we're doing a really similar process. We are converting from between mass and moles, so we will need our molar mass. So the molar mass of C2H2 is going to be 2 times the mass of carbon from the periodic table is 12.011, plus 2 times the mass of hydrogen from the periodic table is 1.008. So that gets us a molar mass of 26.038 grams per mole, which again is our conversion factor, telling us that 1 mole of this substance is equivalent to 26.038 grams of this substance. And we can use that conversion factor sort of in either direction, depending on how our units need to cancel out. So in this one, we are starting with moles. We are starting with 2.5 moles of this substance, which means I need moles to go on the bottom so that that cancels out. My conversion factor, my molar mass, tells me that 1 mole of C2H2 is equivalent to 26.038 grams of C2H2. So in this case, the molar mass, the 26.038, is going on the top, since that is the unit we want to end up in. 1 mole goes on the bottom so that our units of moles cancel. And this gets us about 65 grams of acetylene. So we can use molar mass to convert either grams to moles or moles to grams. And this is something that is going to come up all the time in any chemistry course you ever take, and some other sciences as well. So this is a skill to get really, really comfortable with. It is something that you're going to need for the rest of this course, for any other science courses, or for any other chemistry courses you may take at least. And it's something that just comes up all the time because we are constantly thinking in moles when we do calculations, but when we go to do something in the lab, we really have to be able to weigh it out on the scale to convert it to grams. So really important kind of basic skill for any chemist to have.